A glowing cloud of gas is hiding something that cannot shine. Deep inside the Orion Nebula, stars are racing around an invisible point. Their strange speed suggests that something massive may be sitting where we cannot see it. And if that hidden object is really there, it could be one of the closest black holes to Earth. Before we go deeper, subscribe if you enjoy real space mysteries where the strangest answer is often hiding in plain sight. Because this story is not about a black hole far across the universe. It may be hiding inside one of the most famous objects in our own night sky. The Orion Nebula looks peaceful from Earth. On a clear night, it appears as a soft patch of light below the 3 stars that form Orion's belt. But that peaceful glow is only the surface of a much more violent place. The nebula is a huge cloud of gas and dust where stars are being born, growing, and changing the space around them. The Orion Nebula is about 1,500 light-years away from Earth. That sounds impossibly far, but in cosmic terms, it is surprisingly close. When you look at the nebula through a telescope, you are seeing light that began its journey toward Earth around 1,500 years ago. That means the Orion Nebula is not just a picture in the sky, it is a message from the distant past. For centuries, people saw the strange cloudy object in Orion without knowing what it really was. Ancient observers could see the bright stars of Orion, but the faint glow of the nebula was much harder to understand. Later, astronomers began studying it with telescopes and realized that this was not a simple cloud. It was a giant region filled with gas, dust, young stars, and powerful radiation. Today, the Orion Nebula is one of the best-known star-forming regions in the sky. It is sometimes called a stellar nursery because new stars are forming inside it. The gas is pulled together by gravity, becoming denser and hotter until stars can begin to form. In other words, the nebula is not a dead cloud. It is a place where stars are still being made. And right near the heart of this enormous cloud is a compact group of young stars called the Trapezium. The Trapezium is only a small part of the entire Orion Nebula, but it controls much of what we see. Its brightest stars pour out huge amounts of ultraviolet light. That energy hits the surrounding gas and makes the gas glow. So at first, the center of the nebula seems to have a simple explanation. There are powerful young stars in the middle, and their light makes the surrounding cloud shine. Scientists would expect the stars in this crowded region to move in ways that match the amount of visible matter around them. If the stars move faster than expected, there should be a reason. This is where the mystery begins. Astronomers studying the motions of stars in the Orion Nebula have found something that does not fit neatly into the simple picture. Some stars in the central cluster are moving extremely fast, and when scientists calculate what could be controlling those movements, an invisible object becomes one possible answer. Imagine standing in a dark room and watching several people run around a point you cannot see. You cannot see the object in the middle. But if you carefully measure how the people move, you may be able to calculate that something is there. Astronomers use a similar idea when they search for black holes. A black hole does not have to announce itself with a bright light. In fact, the defining feature of a black hole is that light itself cannot escape once it crosses its boundary. And that makes a black hole incredibly difficult to see directly. Scientists often have to find them by watching what they do to everything around them. The basic idea is simple. Gravity controls motion. A heavy object pulls more strongly than a light object, so if stars near the center of a cluster are moving much faster than expected, scientists can ask a powerful question. What amount of hidden mass would be needed to make those stars move that way? At first, the obvious answer is that there could simply be more stars. Maybe some stars are too faint to see. Maybe dust is blocking them. Maybe the center contains many small objects packed tightly together. But there is another possibility, and this is where the story becomes much more interesting. What if some of the mass is inside one object? What if the object is so compact that we cannot see it directly? And what if its gravity is strong enough to influence the young stars around it? That is the basic idea behind the possible black hole hidden inside the Orion Nebula's central star cluster. It is important to say this clearly. Scientists have not taken a photograph showing a black hole sitting inside the Orion Nebula. This is an inference, a conclusion based on evidence about how the stars move. That difference matters. A black hole can be suggested by data without being directly photographed. Astronomy often works this way because the universe hides many of its most important objects from our eyes. Scientists gather measurements, test different explanations, and ask which explanation fits the evidence best. The strange part is that the Orion Nebula is not some distant and mysterious object that nobody knows how to study. It is one of the most observed star-forming regions in the sky. Astronomers have examined its stars for decades. That makes the possibility of a hidden black hole even more interesting, because if such an object exists, it may have been hiding in a place astronomers have been looking at for generations. The black hole would not need to be invisible because it is impossibly far away. It could be invisible because black holes are simply difficult to detect. The surrounding stars may be giving away its presence instead. So what exactly would a black hole be doing in a young star cluster? To understand that, we need to go back to the beginning. Stars are born from clouds of gas and dust. Gravity slowly pulls parts of those clouds together, and when enough material gathers, the center becomes hot enough for a new star to ignite. But star birth is rarely a calm process. Many stars can form close together. Some may be massive, some may be small. And when hundreds or thousands of stars occupy a relatively small region, their gravity can create a complicated cosmic dance. The trapezium is an example of this crowded environment. Its stars are young, bright, and massive. They are also packed close together compared with the stars around our own sun. The central region has experienced strong gravitational interactions for a very long time compared with the lives of some massive stars. Now comes the first major expectations. Scientists would expect a young cluster to contain many massive stars and many lower mass stars. They would expect those stars to orbit and move under the combined pull of all the matter in the cluster. The motion should tell us how much mass is present, but when some of the fastest moving stars are studied, the numbers become interesting. Their speeds can be difficult to explain with the visible stars alone. One possible explanation is that the cluster once had an even more crowded center, and that leads to a remarkable idea. Perhaps some massive stars collided, perhaps several stars came together during the cluster's early history. If enough massive stars merged, the result could eventually collapse into a black hole. Instead of having many massive stars packed into the center, the cluster could now contain a single invisible object carrying a large amount of mass. That would create a strange cosmic fingerprint. The black hole itself would be dark, but the stars around it would respond to its gravity. Their paths would become clues, their speeds would become clues, even the way the cluster changes over time could become a clue. And there is a number that makes this possibility especially fascinating. Some studies have suggested that a black hole in the Orion Nebula's central cluster could have more than 100 times the mass of our sun. That does not mean it is 100 times larger across. It means its mass could be more than 100 suns packed into an extremely small region. Think about that for a moment. Our sun is already so massive that more than 1 million Earths could fit inside it by volume. Now imagine more than 100 times the sun's mass compressed into a black hole. The object could be tiny compared with the enormous nebula surrounding it. This is the strange contrast at the heart of the mystery. The Orion Nebula stretches across many light years. It contains enormous clouds of gas. It contains young stars that are much larger and brighter than our sun. And possibly, hidden inside all of that, there could be a compact object with the mass of more than 100 suns. But there is a problem. If the black hole is there, why has it not been obvious? That question is exactly what makes black hole hunting so difficult. People sometimes imagine black holes as cosmic vacuum cleaners, constantly sucking everything toward them. That picture is misleading. A black hole does not automatically pull in everything around it from a distance. Its gravity behaves much like the gravity of any other object with the same mass. If our sun were magically replaced by a black hole with exactly the same mass, Earth would still orbit in almost the same way. The planet would not suddenly fall inward. The major problem would be that there would be no sunlight. The important point is that mass controls gravity, not some magical sucking force. So a black hole hidden in the Orion Nebula could sit quietly while stars orbit around it. Unless gas falls toward it, it may produce very little light. If it is not feeding on nearby material, there may be no bright disk surrounding it. The black hole could therefore be almost impossible to spot with ordinary telescopes. That brings us to another important clue. When black holes feed on nearby gas, the material can become extremely hot. It can glow strongly in X-rays and other forms of radiation. Those bright signals can make black holes easier to find, but a quiet black hole does not give astronomers that advantage. The possible Orion object may be exactly the kind of black hole that hides well. Instead of shining, it may reveal itself through motion. The stars become the messengers. Their orbits carry information about the invisible mass in the middle. So here's the next twist. Scientists originally expected the center of the cluster to be explained by the stars they could see, but the motions of some stars opened the door to another possibility. The invisible mass could be concentrated in a much smaller object than expected. And that matters because it changes the story of how black holes can form. Most black holes we know about are linked to massive stars. A very massive star can run out of fuel, collapse under its own gravity, and leave behind a black hole. But a black hole in a young star cluster could have another story. It could be the result of several massive stars coming together. That would mean the crowded center of a star cluster is not just a place where stars are born. It could also be a place where black holes grow. A young cluster could become a natural laboratory for watching the early stages of black hole formation. And if that sounds surprising, there is an even bigger reason to care. Astronomers are still trying to understand how black holes of different sizes form. There are small stellar black holes, and there are enormous supermassive black holes at the centers of galaxies. And between those groups, scientists are interested in black holes with masses from hundreds to hundreds of thousands of suns. These middle-sized black holes are called intermediate mass black holes. They are difficult to find. Scientists have strong evidence for many stellar mass black holes and supermassive black holes, but the middle range is harder to study. A possible black hole inside the Orion Nebula could therefore be more than just a local curiosity. It could help scientists understand a missing chapter in black hole history. Maybe small black holes can grow inside dense star clusters. Maybe they can merge with other black holes. Maybe some eventually become much larger. And perhaps these processes help explain how the biggest black holes in galaxies became seems so massive. But before we get carried away, there is another question. Could the strange stellar motions have a different explanation? Absolutely. Science does not accept a black hole simply because it sounds exciting. Other possibilities have to be tested. Maybe unseen stars contribute extra mass. Maybe the cluster is not in the stable state scientists expected. Maybe some stars were recently kicked into unusual paths. Maybe the measurements contain uncertainties. This is where good science becomes different from a dramatic story, and the most interesting possibility is not automatically the correct one. Scientists have to compare competing explanations. They have to see which one survives when more data are added, and that is why the possible black hole is best described as a mystery, not a confirmed object. The evidence can point toward a hidden mass. The black hole idea can fit the observations. But there is still a difference between strong evidence and direct confirmation. If you are enjoying this mystery, here is something worth thinking about. If you had to choose, would you trust the strange motion of the stars as evidence for a hidden black hole, or would you wait for a completely different kind of detection? Leave your guess in the comments, and if these cosmic puzzles are your kind of story, consider subscribing. Now zoom out from the central cluster for a moment. The Orion Nebula is much bigger than the region where this possible black hole would be. The glowing cloud is a huge mixture of hydrogen, dust, and other material. Hydrogen is the lightest and most common element in the universe, and it is also the main fuel used to build new stars. The bright colors and images of the nebula can make it look like a painted cloud, but those colors are telling us about real physical processes. Different gases give off different kinds of light. Dust blocks some light and allows other light to pass. Stars heat and shape the surrounding cloud. The center is especially intense. The trapezium stars are young enough to be powerful sources of ultraviolet radiation. That radiation changes the gas around them. It can strip electrons from atoms and create glowing regions. This process is one reason the Orion Nebula shines so clearly. So the nebula is already full of extreme activity before we even add the black hole possibility. There are stars being born. There are stars throwing energy into space. There is gas moving around. There are gravitational encounters. And inside the crowded center, something invisible may be affecting the motion of stars. Now consider the age of the region. The Orion Nebula's central cluster is only a few million years old. That sounds ancient from a human point of view. But compared with the age of the universe, which is about 13.8 billion years, it is extremely young. The entire cluster is like a newborn compared with the universe itself. That creates a fascinating possibility. If a black hole formed there through the merging of massive stars, it may have formed very early in the cluster's life. The process could have happened when the stars were even more tightly packed. Gravity could have caused massive stars to interact, collide, or merge, and scientists call this kind of process runaway stellar collision. The basic idea is easier than the name sounds. If many large stars are packed together, some can get close enough for their paths to change. A few collisions can create a larger star. That larger star can interact again. Over time, the center can become even more massive. Eventually, a very massive object may not be able to support itself. Gravity wins, the core collapses. A black hole can be left behind. This would be very different from watching one ordinary star explode and leave a small black hole. Instead, the cluster itself would play a major role in building the black hole. The environment would be part of the formation process. And that brings us to one of the strangest ideas in this entire story. The black hole may not have been hiding from astronomers at all. It may simply have been hidden by the physics of its own existence. A black hole does not need to cover itself with a cloak. It naturally disappears from ordinary sight once there is no bright material around it. The nebula makes that problem even harder. There are countless stars in the background. There is glowing gas. There is dust. There are bright young stars. Trying to identify one invisible object inside such a crowded region is like trying to identify one silent person in the middle of a stadium full of noise. But astronomers have a powerful advantage. They can measure movement. Modern telescopes can track the positions of stars with extraordinary precision. By comparing observations taken years apart, scientists can measure how stars shift across the sky. Those tiny changes can reveal enormous gravitational forces. This is how the universe can expose something that does not emit light. The stars become a kind of natural measuring tool. Their paths act like arrows pointing toward the hidden source of gravity. The key question is not simply whether a star is moving fast. The key question is whether its motion makes sense given everything we can see. If it does not, scientists have to ask what is missing. That missing thing could be unseen stars, it could be gas, or it could be a black hole. This is why the central region of the Orion Nebula deserves attention. The evidence does not come from one strange star. It comes from studying the behavior of the cluster as a whole, and scientists can build models of the cluster and test what happens when different amounts of hidden mass are placed near the center. If a model without a black hole cannot reproduce the observed motions, while a model with a central black hole works better, the black hole becomes a serious possibility. But models are not photographs. They are tools for testing ideas, and this is where the story remains unfinished. The possible black hole has not stepped out of the darkness. No telescope has simply pointed at the Orion Nebula and said, there it is. Instead, scientists are still trying to narrow down what is happening inside the crowded center. That uncertainty does not make the mystery less exciting. It makes it more scientific. There is still something to discover. There is still room for a new observation to change the story. And now the question becomes even bigger. If there really is a black hole inside Orion, how many more could be hiding in other star clusters? The Milky Way contains enormous numbers of star clusters. Some are young, some are ancient, some are dense, others are spread out. If dense young clusters can create black holes through stellar interactions, then these hidden objects may not be rare. They could be scattered throughout our galaxy. Most would probably be extremely difficult to detect. Some might reveal themselves through fast-moving stars. Others might eventually merge with companion objects. A few could become active if enough gas or another star comes close. That means the night sky could contain far more black holes than we currently know about, and the black holes would not appear as dark circles hanging visibly in space. They would be hidden inside the motions of stars. Think about how strange that is. When you look at the Orion Nebula, you see glowing gas, you see stars, you see a beautiful shape, you do not see a black hole. Yet gravity does not care whether something is visible. A black hole could sit in the middle of that beauty without changing the way the nebula looks dramatically. Its influence might be subtle. A few stars move faster. A cluster behaves differently. A pattern appears in the data. And slowly, the invisible object begins to take shape in the minds of scientists. That is one of the deepest ideas in astronomy. We often think science is about seeing things, but sometimes science is about proving that something must be there because of what it does to everything around it. We cannot see gravity itself. We see falling objects. We see planets orbiting stars. We see galaxies moving. We see stars bending their paths. From those movements, we understand the invisible force. Black holes take this idea to an extreme. They are objects that can be almost completely hidden from direct view. Their existence can be written into the movement of matter and light around them. And the Orion Nebula gives us a beautiful example of that kind of detective work. The object is famous, the stars are visible, the cloud is bright, but the center may still contain a secret. There is another detail that makes this mystery feel almost unreal. If the possible black hole is around 1,500 light years away, then even if we somehow watched it change today, we would not be seeing events happening there today. We would be seeing old light. Every observation is a glimpse into history. When you look toward Orion, you are looking backward in time. The stars you see are showing you what they looked like long ago. The possible black hole, if it exists, is part of that same ancient message. Astronomers are studying a region whose light began traveling toward us before modern science existed. That gives the story a strange feeling. The black hole may have formed millions of years ago. Its gravity may have been shaping stellar motions for ages. And only now, using advanced measurements, are humans beginning to ask whether something invisible sits at the center. But what would happen if scientists eventually confirmed it? First, it would give us a much stronger case for black holes forming inside young star clusters. Second, it would give astronomers a nearby laboratory for studying an intermediate mass black hole. Third, it could help explain how black holes grow from relatively small objects into much larger ones. It could also change the way scientists think about star clusters. Maybe clusters are not just collections of stars. Maybe they are active environments where gravity can build increasingly massive objects. The center could become a kind of cosmic engine, changing as stars interact and merge. And if future observations show that there is no black hole there, that would still be important. It would force scientists to improve their models. Maybe the fast-moving stars have another explanation. Maybe unseen stars provide the missing mass. Maybe the cluster's structure is more complicated than expected. That is the part of science that often gets lost in dramatic stories. A surprising result is valuable even when the original idea turns out to be wrong. A failed explanation tells scientists where their understanding needs to improve. So the real mystery is not simply, is there a black hole in the Orion Nebula? The deeper question is, what is causing the stars in that crowded center to behave the way they do? That question can be answered only through careful measurements, and the tools for doing that keep improving. Space telescopes can see through some of the dust. Ground-based telescopes can track stellar positions. Infrared observations can reveal objects hidden by clouds of material. New surveys can measure huge numbers of stars across the sky. Every new measurement can change the picture. A star may move differently than expected. A hidden companion may be discovered. A model may fail. Another model may fit better. The invisible center becomes less mysterious, one piece of evidence at a time. There's also something beautiful about the location. The Orion Nebula is not some tiny, forgotten object. It is one of the easiest deep sky targets for amateur astronomers to recognize. People around the world point telescopes toward it. Some can even see it with the naked eye under dark skies. That means the possible black hole is hidden inside something humans have been observing for centuries. You do not need to imagine an unknown corner of the universe. You can imagine the familiar shape of Orion hanging above the horizon. And somewhere inside that famous region, an invisible object may be influencing the stars. If the black hole exists, it does not threaten Earth. This is important. The Orion Nebula is about 1,500 light years away. That is an enormous distance. There is no reason to think a possible black hole there is going to travel toward our solar system or pull Earth away from the sun. The danger is not the point. The discovery would be about knowledge. It would teach us how gravity works in crowded star clusters. It could reveal how massive black holes form. And it could show us that some of the most important objects in space can remain hidden even inside the brightest regions. Imagine looking at the nebula. After hearing all of this, the bright cloud would look different. The trapezium stars would no longer seem like simple points of light. Each star would become part of a larger gravitational story. Every fast-moving star could be carrying information about something we cannot see. That is when the mystery becomes personal. Humans have always looked at the stars and wondered what is out there. We built larger telescopes. We launched observatories into space. We created cameras that can detect light our eyes cannot see. And still, the universe keeps showing us that there are things hiding between the visible pieces. A black hole at the center of a famous nebula would be a perfect example. It would remind us that seeing is not the same as understanding. A beautiful cloud can hide extreme physics. A group of young stars can hide an object more massive than 100 suns. And a familiar patch of sky can still contain a mystery. The most important part is that the story is not finished. Astronomers will continue to measure the stars. They will improve their models. They will search for signs that could support or weaken the black hole idea. Future observations may make the evidence stronger. They may also reveal something nobody expected. That uncertainty is exactly what makes astronomy exciting. The universe does not give us answers on demand. It leaves clues. We have to follow them carefully. The Orion Nebula has already taught us a huge amount about how stars are born. It has shown us how young stars shape their surroundings. It has helped scientists study gas, dust, radiation, and gravity. Now it may also be helping us understand one of the darkest objects in the universe. And perhaps that is the strangest part of all. A black hole is famous for being dark. A nebula is famous for glowing. Yet the two ideas may meet in the same place. The glowing gas tells us where the action is. The stars tell us how gravity is working. And the missing light may tell us that something powerful is hiding in the center. So the next time you see Orion, remember what you are actually looking at. You are not just seeing a pattern of stars. You are looking toward a giant stellar nursery about 1,500 light years away. Inside it, young stars are moving through a crowded environment, and buried somewhere in that complex region may be an object that cannot be seen directly. The possibility of a black hole there does not mean scientists have solved the mystery. It means they have found a question worth chasing. And sometimes the biggest discoveries begin exactly that way, not with a perfect image, but with a strange movement that refuses to make sense. If future observations confirm the hidden black hole, we may look back at these stellar motions as the first clues. If they disprove it, those same observations will still help us understand the Orion cluster better. Either way, the stars are giving us information. We only have to learn how to read it. So here's the final thought. The universe may contain countless objects that are invisible, not because they are far away, but because darkness is part of what they are. Some may be waiting in distant galaxies, some may sit inside ancient star clusters, and one possible example may be hiding inside a nebula we can see with our own eyes. Would you want scientists to confirm a black hole at the center of the Orion Nebula? Or would you rather discover that the stars are revealing an entirely new mystery? Tell us what you think in the comments. And if you want more stories about the strange things scientists are still trying to explain, subscribe and turn on notifications so you do not miss the next discovery. And if someone you know loves black holes, strange stars, or the hidden side of space, send this story their way. Thank you for watching and keep looking up.